Now, another definition related to function is bijective function. This is one of the form of function. A function f from x to y is said to be bijective if f is 1 1 and onto 1. That means the function is called bijective it is if it is injective and surjective both together. Now, next term in the function, which is composition of function. Suppose that there are two functions, first is f and other is denoted by g. F is the function from set x to set y and g is another function from set y to set z. Then GOP denote the composition of function from x to z. Here GOP such that the function from x to z. The figure is given that three non-empty set x, y, z. Suppose that the element of x is the set of x is the element of set x, y is the element of set y, and z is the element of set z. F is the function which is associate each element of x with y in such a way fx equal to y. Similarly, z is the element of f and z is the element of set z such that gy equal to z. If we combine both the equations, so we can write gy replaced by fx equal to z and gfx is indicated by gofx. So x GOP image of x is z. So GOP is the composition of function from set x to set z. So GOPx can be written as g of function fx. Similarly, for x can be indicated by function f of gx. Generally, GOP is not equal to 4. Thank you. Now we start with inverse of a function. Let f be a function from x to y. Then inverse of f exists if f is bijective. F is bijective. If f be the function from x to y, then inverse of f exists if f is bijective. That means if f is 1 1 and onto both, then we can say it is bijective. In another way, if f x to y be a function, then there exists be a function, then there exists a function g y to x such that GOP equal to ix and for equal to I. This is another way for finding the inverse of a function. If f is the function from x to y, be a function, then there exists a function g y to x such that GOP equal to ix and fog equal to iy. So then g is called inverse of f. Now we are taking some problems based on composition of function. If f is the function from real set of real number to set of real numbers such that fx equal to 3x plus 2, we want to find f of x. So how can we solve this type of questions? Solve fx equal to 3x plus 2. Now f of x equal to f fx, this equal to f of 3x plus 2, f of fx, and fx is given 3x plus 2. So now this is again work as x. So now fx can be written as 3, the value of x is 3x plus 2, open the brackets, we have 3 3 is 9x plus 6 plus 2, so 9x plus 8. So for x equal to 9x plus 8. Now I am taking again one more question. F be a function from R to R and G also a function from R to R such that fx equal to mod x and gx equal to mod 3x plus 4. Find fog. Solve. So how can we solve this type of question? fx equal to mod x and gx equal to mod 3x plus 4. This implies that for x equal to f of gx implies that f of mod 3x plus 4. Now this mod 3x plus 4 work as a x. So again fx equal to mod x equal to mod of 3x plus 4 equal to mod 3x plus 4, because mod x equal to mod x. So for x equal to mod 3x plus 4. So this is the question. F is the function from R to R. G also a function from set of real number to set of real numbers. We want to find here fogs. Whenever the fx is defined as mod x, gx also defined as mod of 3x plus 4. So we start with fog x. This can be written as function of gx. F gx is defined as mod of 3x plus 4. So now fx again mod x. So mod of 3x plus 4, because mod of the mod x is written by mod x. So this is the value of fog x.